Okay, here we go. Okay, number 6 in the green. 6 in the green is a good example of a problem that you have never seen before, but it does not have any concepts you aren't familiar with. So it's a great example of, okay, taking the test, this suddenly appears. And you've got to figure out how to come up with a valid answer. They tell you that the graph of f is the top graph up here, and that one of the graphs below would be the corresponding graph of f prime. Okay, so the concept you are starting out with using is the idea that every y coordinate, memorize this phrase, every y coordinate on the f prime function is simply the tangent slope on the f function. That's what f prime means. F prime is the derivative of f, therefore every y coordinate on f prime represents an instantaneous rate of change on the f graph. I need to say that again, just wait. Okay. So you can say it multiple ways, and you've got to know all of them because they'll test all the different ways. F prime is the derivative of f. F prime is the derivative of f. What does that mean? James Jackson Brown. I know they're together. You see, it's just Jackson Brown. So it's awesome. Like some James Taylor. So. Now I lost track. F prime is the derivative of f. That means that f prime's y coordinates, every one of them is a tangent slope or rate of change of f. Every point you see on f prime is a tangent slope or rate of change of f. Here's a simple example. Raise your hand, please, if you can tell me at that spot right there, what would you say the tangent slope of f will equal? Hands up. That spot, Brooklyn, what would you say the tangent slope of f would be?
6.
So, 2 points for Brooklyn. The y coordinate of f, no, you're good. The y coordinate of f would be 6. Stay with me, Brooklyn. What's the slope at that point?
0.
0. How many knew that? Point, 2 more for Brooklyn. The tangent slope right here is 0. Questions? Okay. That means, let's see, I could write the following statement. I could say, at about x equal, it's about negative 1.7, the tangent slope of f is 0. So, on the f prime graph, at that same x coordinate, the y value will equal 0. That's the connection you have to memorize between f and f prime. Questions? So that means when I come down to this possible f prime graph, I go to an x coordinate of 1.7 negative. I find a y coordinate of 0. That's a match for those 2 points. Like at x equal negative 1.7, so far the graph here of f matches this a version of f prime at 1 point. Because the y coordinate here is exactly the same as the tangent slope on f. Oops, come on. Does anyone need me to talk more about that? Sweet. So let's see if we can find some other points that are easily identified. So I look back up here on f, and I note, okay, here's another place where the tangent slope is 0. So at x equals 0, the y coordinate on f prime should also equal 0. Sure enough, right there, the y coordinate on f prime is equal to 0. So far I have 2 points matching. I go over here, this y coordinate, sorry, this tangent slope is 0. This y coordinate is 0. I now have 3 points that match. So at this juncture in the problem, item A so far matches at least in 3 spots. I've got to find a graph that matches in all spots, but at least I've started. So, question? Cool. I want everyone to vote now. I've identified 3 places on F. So I have 3 points on F. Where the tangent slope of F is 0. So I must have the corresponding points on F prime. So I'll abbreviate, corresponding points on F prime must have y coordinates of 0 in those same spots. So identifying those 3 points sometimes will allow me to eliminate some of the possibilities here. Sometimes it doesn't. So this means identifying these 3 points was helpful. This means it wasn't helpful because I didn't eliminate any of the answers. Show me your thoughts. So this means I feel like identifying these 3 points on F, where the tangent slope is equal to 0, was helpful in that it eliminated 1 or more possible answers. This means that was a useless exercise because I didn't eliminate anything. All of the answers are valid still, but they all match up, at least in those 3 points. Show me your thoughts. Useless clue, valid clue. Okay, if you're doing this, give yourself a point. It's a useless clue because, look, let's get somebody to help me. I know your names pretty well now, so I will start calling on you at random. I want you to get the feeling in this room that if you give me the wrong answer, I'll just kind of help you find the right answer, so it's no big deal. If you're like, you just are blank, you just say, I'm just not sure. Like, there's no shame in saying I don't know. So if I call your name and you just don't know, just tell me you don't know. Just move on, okay? We found 3 points on F where the tangent slope is equal to 0. That means the 3 corresponding points on F prime must have y coordinates of 0, like this. So really I could write 2 more of these statements. I could say F prime of 0 must also equal 0, and F prime of positive 1.7 must also equal 0. Questions? But that's a useless clue because as I go from graph to graph, all 3 have that happening. So not helpful. I haven't eliminated anything. I still wouldn't forget this idea though, because I've seen a lot of AP questions where you still have to remember that the tangent slope on F is the y coordinate on F prime. So it wasn't helpful here, but it is helpful in other places, okay? Awesome, next thing. So now we're going to go to Danica's chart and just find something else to find a match with. So we'll go to Ethan. Right here, Ethan, what characteristic would you say, like we only have a couple of choices. You can either say F is increasing or decreasing, or you can say F is concave up or concave down. Okay. So right here, what characteristic would you assign to F?
Increasing.
Tell me to stop when F stops increasing.
Stop.
Good, 2 points for Ethan. So, for those x coordinates where F is increasing, the valid F prime graph must have y coordinates that are positive. Okay? So I look down here to see if I can find that. Right away I'm feeling good because right here, these y coordinates are not positive. That's a problem right away. If this graph of F is increasing, these y coordinates would have to be positive. They're not. That one's done. Questions? Go like this, A, B, C, D, or I don't know, and show me what other graph is eliminated. Show Tell me what other graph cannot be the right answer based on the clue that Ethan gave us. What other one cannot be the answer? If you're doing 2, give yourself 2 points. That one's done. Questions? Now you just pick something else. We'll go to Dylan, E-Y-L-A-N. Fenton, F-E-N-T-O-N. Okay. Let's just go here, I don't know. So tell me what characteristic you want me to identify right here for F, Dylan.
Just go with pace decreasing.
Tell me to stop when F stops decreasing.
Stop.
Let me look up, get Dylan a ticket for this one. That is a spot that I agree 100% with you. It certainly appears that F is going kind of flat. You simply have to memorize that when you have curves, what's really happening is every single y coordinate is actually lower than the previous. There's a place where the tangent slope is defined to be 0, but if you looked at every dot you encounter is lower than the one before it. So it really is decreasing the whole way. Is that okay?
Yeah.
So it goes down the whole way, like so. That means we are looking for a graph of f prime that in that entire span has negative y coordinates. Show me if you know the answer. So A, B, C, D, show me if you know the answer. Again, if you don't know, you do this. So what is the correct answer based on that clue? If you're doing this, give yourself 3. So we know that we've got to have, see, F is decreasing, and that begins right at about, so F is decreasing for about negative 1.7 x to about positive 1.7 x. So F prime of x has to be less than 0 for the same span. And the only graph that meets that characteristic is right here. All of these points are less than 0. There's one that's equal to 0, not really a big concern. All the rest are negative. This one certainly doesn't work because these are all positive. Questions? Please.
So, on the original graph, one of them at the end of the line, one of the points is going down and then one of the points is going up. So do we not worry about matching that with the answers? Like,
Slow down for a second. So you're looking at F.
yes.
And everybody, hey, look, make sure we stay away from, of course, the word it. And you're doing fine, but the other thing that will help is to stay away from like original graph, that graph. Just be very specific, F, F prime. So on F, you're looking where?
Yes, so the lines are going in different directions at the end.
The lines are going different directions at the end.
Yes.
That's what you mean. Like this one's
Yeah.
going this way, this one's going this way?
Yeah, so I just wanted to clarify that when we're looking at f prime, that doesn't matter when you're comparing it. Like, you don't have to worry.
There's a pattern that exists for what are known as polynomial functions that, with regard to what you're looking at. It's not a pattern I've memorized because it only applies in specific cases, so I don't worry about it.
Okay.
I just always go right here and just say, you know, right here is F increasing or decreasing?
Increasing.
Increasing. So that means from x equal 1.7, in fact, write it like this, for x greater than 1.7, F is increasing. So for x greater than 1.7. F prime must be positive, which means greater than 0. That's all I look for.
Great, thank
And I
you.
go to item C here, and hey, sure enough, these are all positive. They'll just keep being positive.
Great.
Does that make sense?
Yeah,
Two more.
thank you.
Very good. Anybody else? Awesome. Go to number 9.